Okay, so this was the first approach to solve the problem using relative velocity. Now let's move on to the second approach to solve the problem. Suppose A moved certain distance. A started from here, B started from here, A moved to a new position A dash, B moved to a new position B dash. Then this is the distance between A and B at any time t. So suppose they started from here, and after time t, A moved to A dash and B moved to B dash. Now A is moving with 20 meters per second. So in time t, A is going to cover 20 t of distance, and B is moving with 15 meters per second. So in time t second, B is going to cover 15 t of distance. So this will be 500 minus 20 t, and this distance is going to be 400 minus 15 t. If we apply Pythagoras theorem, then A dash B dash square, which is the hypotenuse of this right angle triangle, would be this. Now this is the expression of distance between A and B at any general time t. Now what we have to do is we have to differentiate this function with respect to t and equate that to 0. That's what we do to calculate maxima and minima. You remember from the calculus? That's why we studied calculus before starting physics. So you have to differentiate this, and you have to equate the differential to 0, and that particular time that will you will get from equating the differential to 0. At that particular time you will get the maximum or minimum value of A dash B dash. Okay, so but A dash, we want the minimum value of A dash B dash. If we differentiate this function, this is the function of A dash B dash square and not A dash B dash. But the thing is, when we get the minimum value of A dash B dash square, at that instance we get the minimum value of A dash B dash, because it's just simply square, right? When A dash B dash square is minimum, at that particular instant A dash B dash is also minimum. But if you go on differentiating A dash B dash, then there will be a square root, and the differentiation will become a little complicated. So we are not doing that. We are not differentiating the function of A dash B dash. We are simply straight away differentiating the function of A dash B dash square, because the time, the t, will be the same. Either you minimize A dash B dash square or you minimize A dash B dash. Okay, so let's differentiate A dash B dash square with respect to t. What you will get is, now you should be very handy in differentiating this kind of function, because you must have differentiated 100 times before when you solve the exercise in calculus. Right? So when you do it, you will get minus 40 minus 20,000 plus 800t minus 30 minus 12,000 plus 450t. This is going to give us 1250t is equal to 32,000. From here we get t is equal to 128